Alright, this is a video going over the third quiz from Chapter 8, which was one proof and one equation. The proof, most of you did very well on this, so I'll go over it. Actually, it's a pretty simple proof that most of you would start on the left side. Okay, so the correct thing to do is to actually write that side again. Okay, now we really should only do one step at a time, so I know that a lot of you recognize that 1 minus cosine, or 1 minus sine squared x is cosine squared x, and actually 1 plus cotangent squared is cosecant squared. That was good to recognize that, but we should only really show one at a time here. So I'm just going to put cosine squared x over 1 plus cotangent squared x. 1 plus cotangent squared x because if we have this basic Pythagorean identity and we divide everything by sine squared, we will get 1 plus cotangent squared x equals cosecant squared x. So this down here is cosecant squared x. So that makes it nice. Cosine squared x over cosecant squared x. Oop, not cosine, cosecant. Alright, we know cosecant is 1 over sine. So I'll change this to cosine squared x times 1 over sine squared x. And then from there we should be able to finish it. We should get what we want. Cosine squared x sine squared x, which is equal to the right side. Pretty straightforward proof. You know the identities, no problem. Alright. The back. Now we're asked to solve an equation. And there were a few approaches to this that people could take. One approach was to divide both sides by sine x. Some people just canceled the sine x's. However, you have to be really careful when you do that. Because when you're canceling those sine x's, you're really not canceling them. You're dividing both sides by sine of x. Well, sine of x could actually be 0. If sine of x were 0, this equation would be true. So sine of x equal to 0 is one solution to this equation. So if I'm going to do this, if I'm going to divide everything by sine of x, and I have to put to the side that sine of x could be 0. Okay, so that was one thing that people did. Another thing, which is a little bit more foolproof, where you don't have to remember anything like that, is let's subtract 2 sine x from both sides and basically set this thing equal to 0. And then we can factor. And we see that a 2 can come out, sine x can come out, and then we get cosine squared x. Actually, 2 cosine squared x minus 1 equals 0. So now you see that you get, well, we can divide both sides by 2, and that'll get rid of the 2, but we get sine x is equal to 0. As you can see, that's the same thing that would have happened if we divided both sides by sine and then noted to the side that sine of x could be 0, and then we get 2 cosine squared x minus 1 equals 0. Alright, when is sine x 0? Well, I can put 0 or pi. I'm not going to put 2 pi because you notice here that 2 pi is not included in the domain of what we're looking at. Solve this equation. I get 2 cosine squared x equals 1. Cosine squared x equals 1/2. Square root both sides, and I get cosine, absolute value of cosine x equals the square root of 1/2, which you should recognize as the square root of 2 over 2. Alright, a lot of people got stuck right here and didn't know what to do, but the square root of 1/2 is this. If I rationalize this, I get the square root of 2 over 2. Okay, so that's a special value, and since it's the absolute value of cosine of x is equal to this, we have that. Okay, so if I draw a little unit circle, when is the cosine equal to positive root 2 over 2? It would be here or here. When is it equal to negative root 2 over? It would be here or here. And those are pi over 4s, really. So x is equal to, this one's pi over 4. We've got 3 pi over 4. We've got 5 pi over 4. We've got 7 pi over 4. So I have 6 answers to this equation. Okay? Again, look at all of it at once. The idea of getting everything to one side and then trying to factor is a good idea. There are other approaches. Dividing both sides by some function, you have to be careful. It's legal as long as that function couldn't be 0. If that function could be 0 and that'll make the equation true, you're going to have to, note out to the side that that function could be 0, and you're going to have to solve that.